Welcome back to Ye Old Foundry, ladies and gentlemen. My name is Tom Kitchen, also known as Sandrammer. You'd probably find my videos by way of Sandrammer rather than Tom Kitchen. I got an interesting little project to do. But before I tell you about the actual project, I'm going to give you some background information, background knowledge. Okay, when I was in the Navy, those times that, we got underway, well, we couldn't make molds and pour molds underway because, the ship is doing this number, right? And it absolutely, there was the stupidest idea to try and walk with molten metal in a crucible. And I'm not talking a little tiny crucible that big around, I'm talking one that's about that big around, and we usually brought it up to about 3/4 full so that we'd never run out of metal on the the molds that we ever poured. But that was one of the major rules that I had, is that we could not do any pouring or running the furnace and pouring underway because of the inherent instability of the ocean. So we usually wound up having some kind of either drills during our working hours, or in the foundry we might do some chipping and painting, because we usually, when we were in, tied up along the pier, we almost always had to make stuff and had very little time to be able to do any chipping and painting and, dressing up the foundry. We would have, of course, all of our material or all of our equipment in the shop would have scheduled maintenance that's done, and that was easy to have everything stand by and not have people ramming up and pouring stuff while we were doing the maintenance. Everybody got some kind of maintenance to do in the shop if it was during that week, and at least on 1 or 2 days during that week we got maintenance stuff done. But when we were underway, we couldn't do any of that. We couldn't do any of the actual work. Okay, we would possibly doing maintenance that we couldn't do while we were in port. We would do the chipping and painting and making things look nice and clean. We basically just really dressing up the shop. Once we got all that stuff done, really couldn't do a lot of stuff other than also we might do training. I liked to do training at least a portion of the day, like in the morning or the afternoon, depending on what's going on. Maybe there's some drills that suddenly, drills being, whether it be a firefighting drill, whether it be a general quarters drill, which is like if we're being attacked kind of thing, and so forth. But if it was a free day, one of those days where we were doing nothing, I'd let our people in the shop go visit other people. Maybe go up to the bridge where all the steering is taking place, and everybody's watching, looking at the radar, watching the operations. Maybe even looking at the big eyes, and big eyes by, I mean, it's the pair of binoculars, but they're huge. The ends of them, the biggest end was probably about that big around, and the space between the eyeballs and the big end was maybe about that long. So you could see a long way, okay? And so, I've done that myself. But what I would wind up doing, more often than not, I would try to learn new things. All right, and that's usually the new things by way of the molder rate. Okay, I was the senior guy. I was the chief in my last ship, and I was the last 2 ships. I was either a first class. Well, I was a first class on the Sierra, and then I was a chief on the Yosemite. And so you're in a position where you're supposed to know stuff. Okay. Like the people, the older people, in the civilian world, they're supposed to be wiser. They're supposed to have some good background knowledge, maybe even be the masters of their trade. Maybe some people, they just didn't bother. But I tried to learn some interesting stuff. Now, one of the things, I've never used this technique before, but it was one of the things that I saw, and I kind of committed it to memory. It's not that hard to commit to memory. Let me assure you, it's not that hard to commit to memory, and you'll find out. Now, I'm going to have a picture come up right about now, and this picture I'm going to explain what it looks like. Now, sometimes, let's say that hook that you see there on the upper left, it's one of those that it's not a solid hook. It's one of those where the hook can rotate, or the part that's connected to the hook, the eye of this hook, it can rotate depending on what's going on. Let's say you're starting to lift something real heavy, and you don't want this thing to rotate, real fast around. But once you start putting some weight on it, the eye on this assembly just might rotate and relieve some of the stress from the cable that's being attached to it. Okay, so that thing on the upper left, you're seeing one side of it where you can actually see the hook. It's giving you a cross-sectional idea of what it looks like if you cut it in half. The cross-hatching piece you see there, the part that's been a little bit of darkened out, that gives you the idea that the part where the inside of the hook is much bigger around, much thicker than the outside edge. Okay, if you take a look at the right-hand side of those image A, or drawing A, you can see the part that would rotate, how big around at the very bottom of the eye it might have been. Okay, on part B, they're showing how somebody might make up a box, and the way these guys worked, this one, they were making a core, okay, to make this whole thing. All right, so the box they would make, then they would put the pattern inside this the box, and it looks like they made it stay still by using dowels. Okay, at least one dowel I see, and the only reason why they would have that is if they had it to keep the item in there from rotating or moving. They make the core, which is what drawing C looks like, and you can see how they were going to be doing it. Okay, you make the whole thing with a single pattern, and then when you take everything out, you take the eye off and you put the hook back in. The hook then is anchored in place, and you can see where there's the mold cavity in there, and that's where the molten metal would be poured in there. Okay, now they're going to have another half. As you can see on the bottom, they're going to have two pieces of core material, and then the core material is going to be supported by a regular green sand. Okay, now take a close look at C. You can see on the left hand side they've got it written sand coated surface. Okay, the reason why that is because you don't want the mold cavity, the metal coming into the mold cavity, to bond with the precast hook. Okay, and so if you get it coated with something that the metal can't go through and bond with the metal of the precast hook, then as soon as you take it out and you clean it up, or you clean the casting up, get rid of the excess metal, you start turning that eye, and it'll rotate freely, because as soon as you put pressure on it, the sand in there will rotate around, will bust up into dust, and will fall out in between the hook and the eye. Okay. Now I saw that, and I said that that would be a neat thing to do, but it would also, you know, we just nothing ever came up where we could apply that. Coming into the future, or back to where we are now, I've been on YouTube for what, a couple of years now, but over the amount of time that I've been part of YouTube, I've watched a lot of you machinists out there, you know, have to replace parts on your lathes that got wore out over the, you know, the ages or the years of, or decades of it being used. Okay, I've watched Keith Rucker work on it, Mr. Fenner work on it, A-Bomb 79 work on them, you know. But the one that really attracted my attention when I saw that and reminded me of this one technique that I showed you was when they had to make a new crossfeed nut for a new you know, shank, or I guess you might call it a shaft. I don't know. Anyway, let me show you another thing. I'll take you off this container, this thing here. It's the same idea of what I told you about before. Here's your hook, here's your eye, here's your hook, here's your eye, and you would have a piece of cable going through it, and the cable would be secured not very far away from the hook, and a little bit of cable past this, so, you know, once in a while a person could watch that and make sure when they're lifting that that piece of cable isn't being pulled through the clamps and might let loose and everything fall. All right. Now, if you're going to be using a regular green sand, you know, molding material, what you do is you have to have a whole pattern made, okay? So that, you know, you would have a whole pattern made, you would have a hook pattern made, and then you would have an eye pattern made. Now, once you got those things made, you would ram up the hooks first. However many of these things you'd have to do, you would ram up the hook first so that this was all cleaned up and ready to go, and you would, you know, they would be like this, and right in here, right in the area of the on this flat right here, and underneath, well, part of it, you could actually do the whole bulb and shaft. You spray that with something that's going to act as a barrier from, you know, to keep this from bonding against that, okay? And so the spray mold wash, or any kind of like even some of the non-flammable mold or a pattern, you know, washes, you spray this inside there just to keep this eye from bonding with that part right there, okay? So as soon as you got the pattern made, you'd ram up the pattern, and you would have this whole thing would be a mold cavity, right? Well, as soon as you take the pattern out, as soon as you've got the mold all ready to go, you take the pattern out, you put the hook inside there, okay? And then the only thing you have left is you have this mold cavity right here ready to be poured. Now, if I was pouring it, it'd be like, we're looking from the top view of the drag, right? We're looking straight down at it as if we're working on it. What I would do is make a ingate that would pour this way fast, make an ingate that would pour this way, and then both of those would fill that up right away as soon as back pressure came in, and they'd fill that up. And then twice as deep as this ingate would be the runner, okay? So that this can come all the way to the end push whatever sand might be in there, push whatever dross might have been formed when it fell down into the splash basin, and then back up and then go into the mold cavity. That's the splash basin, and that's the way it would be made. Okay, put the the finished cope on top of it and pour that in there. Zoom in, fill this up, solidify, break it out, cut that off, take off the flash, whatever flash might be in there. Then you start working that around, and whatever it is you used in here to act as a barrier, whether it be a mold wash or a core wash or any of those, you could use that in there, and then that would be able to be turned. Not needless to say, after that's all done, you turn it into quality control, and then they put them under weight testing, and whatever works goes, and whatever doesn't work we make more of. Okay, normally those are made out of steel in the Navy, unless we made something out of high strength yellow brass, which is tensile strength wise is as strong as some of the lower tensile strength steels, like just mild steel. The high strength yellow brass, we measured it, and it was as strong as them. So if you had to have a hook that was going to be used by the divers, let's say, and always being immersed in salt water, you needed something that was going to be highly corrosion resistant from salt water, we'd make high strength yellow brass. Okay, but most of the time, 90% of the time, these hooks would be used outside of the water, and they would be made out of steel. Okay, now let's put you back. I'll put you back where you were so that you're steadier. Okay, now coming up to the part of the experiment. Many is the time that I saw some of you machinists have to replace the nut and maybe even the shaft on the crossfeed on your nut, or the nut on your crossfeed and on your shaft, or any of the other parts that has a screw and then has a nut on it. Excuse me. I had a good idea what I have to do, but I'm going to, because I don't yet have it set up in the foundry here to pour brass and bronze. That's in the future. I'm going to be testing this technique with aluminum. Okay, so what I did is I went and bought a short chunk of Acme threaded shaft, and then I made a simulated crossfeed nut. Okay, this might help somebody, this kind of thing, but might be way too big for almost anything. I don't know if these would. I think I saw the Acme thread on some of the drive, the automatic drive mechanism for the lathes. Anyway, this would be, because most of the time I saw the folks, whoever might have been associated with it, was fixing their crossfeed nuts and screw. And so let's pretend that somebody is going to send me a new shaft, okay, and their old crossfeed nut. Now the reason why it can be the old one is because the only part that is wore out usually that I've seen, okay, was the female threads on the inside here. Okay, so let's say I've got the new one, I've got the old one. I take it, I put the old one on. Of course, I'd be screwing it on, and then put it around in the middle. It can be up here, it can be down here, but basically just put it down in the middle. And then I think you almost got the idea. I would have this in the sand, you know, half in the drag, half of this would be in the drag, half of it would be in the cope, okay? Now, of course, I don't have a screw, a marker, so I'll be right back. Okay, I think you're back on. Yes, you are. Okay, now, so here's the deal. What I would do is I would use one of the you know, stack molds, fill this up, ram this up nice and tight, slick it off, put this on, you know, in here, and tap it down halfway, whichever way has room. Maybe, yeah, tap it down halfway, and then, you know, clean it up. Put the second one over the top, and this is going to be halfway down here. Then ram up the top, okay, and then make your runners and ingates, and we'd probably put a riser, but this is basically what it would look like. You're looking at it from the top, okay. You're going to have the screw, you're going to have the Crossfeed nut in place. I take and ram this all up. I take it out. You take this off of the screw. You put the screw back in. After you spray some stuff on it to act as a barrier. You know, this one is only one spray, and I was testing it. What it is, it's exactly like, excuse me, it's exactly like a mold wash that we used to make all the time in the foundry. That was mostly isopropyl alcohol and some highly ground up, you know, super microfine carbon or graphitic carbon. Okay, you mix it up real well, and then you could do either one of two things. You can either spray it into the mold cavity. This is how we used it way back then. Spray it in the mold cavity, or we could you know, paint it with a very, very fine brush. Pardon me. But in this case, what we would do is we would spray it 3 or 4 coats. You know that that metal is not going to attach itself to this. It's simply going to wrap itself around the shaft, go into the gaps in where the bottom of the threads are for the Acme threads, and form the male threads around the female threads. And that's the idea that I had. Okay, the same exact way that you would have the eye in that hook and eye assembly, and then you would move the eye around and free it up. The same thing would happen with this. Once I've taken this out, removed the Crossfeed nut off of it, I would put the screw back on into the mold, okay, and then pour it. You know, put everything together and then pour it. It would come down in the splash basin. Once that filled up halfway, it would follow the runner. Once that would fill up, then it would start to go into this cavity right here. When you pour it into that, it'll wrap around with no gaps. It'll wrap around all those threads in there and make a exact copy in the female form of those male threads. Okay, And then once that starts filling up, let's see this. Once it starts filling up, it'll be just kind of like that. It starts filling up from here, back over here. This will all fill up too. And you pour it fast so that nothing can freeze up at all on you. And then as soon as this is all full, this all backs up into, do I have one here? I thought I did. I was pretty sure that I had me. Yes, there it is. Now this is a blind riser, and the reason why it's blind is because it's not going to be exposed to the person's eye. You can't see it. Okay. This portion of it, this is called a cracker core, and what that does, it improves the amount of atmosphere that can go in there and allow the metal, when it's shrinking, to fall or go down towards the area that it's trying to feed, right here. Okay, so right inside here you would see the depression or the gap or the void that it forms when this, being the reservoir of metal, let's see if I can get this. I would have it something like this, or actually it'd be more like this, because it'd be on this portion on the cope. It'd be halfway up, and then there wouldn't be any sand in here. It'd be a big, nice opening where this would be in place, and this would act as a reservoir, so that there's no shrinkage right in here, which is where it would be if I just left that alone and just poured it straight into there and this solidified, because it's right in here is where the biggest cross section of this metal is. So it'd be right in here. You would have a shrink, and nobody wants a shrink on their screw, or rather Crossfeed nut. We'd want to really have it nice and solid so it lasts forever. Now, there's several different things that would be an advantage of doing it this way, instead of somebody just taking the old nut and making a new nut, and all the bother you would have with being able to drill it out and and the rest of it, and make the threads inside there. This would take a tenth of the time, and you absolutely would not have any possibility of having clearances in here, no gaps. Okay, because it would the only clearance you might have in there would be what was formed by the thickness of the stuff we sprayed in there, right? If we want to have it fairly thick but still form around the male threads, you might use something a thicker wash, like a clay wash or a silica wash that we normally would use on molds, and then they would be thicker. But here's the deal: if I was doing this and I was going to do it the way I thought it would work real well, if you wanted, and I mean, it's going to be tight, all right? It's going to form exactly like a hand in glove, the female threads around the male threads. But if it's too tight for the person who's going to be using it, you could always have this on the shaft and then putting a lapping compound in there and just lap it until you get the kind of clearance you want. Okay? Or if you had to, you could go ahead and use some other method. But lapping, you move it up, put the lapping compound in there, or you could put the lapping compound in the female threads inside here, and then just move it up and down until it has the clearance that you like. Okay, so that's the experiment that I intend on doing. Well, of course you're going to be watching, but I'm going to be making it out of aluminum. And the part that I'm actually going to double check and make sure it actually works is the ability of the material to wrap around and form around the male threads to make female threads that are as solid as if somebody did it with a tool, with a threading tool. Well, an Acme threading tool. Okay. If this works, any of you guys that not only have, you know, a machine shop that needs to have this performed, and you had, like Keith Rucker has most of what he needs when it comes to making up his foundry, he could go ahead and do this same way. He would have the piece that he needs to replace. He would have the you know, the flasks that he needed, and he could pour it and, you know, just clean up all the outside out here, and then it would be done. Okay. I don't know, maybe somebody's done so many of these that it would be too much work for them to do it the other way. But for those of you who thought ahead in time and not only have a machine shop, but have worked, have established a small foundry where you can make small parts, you're going to find that this is going to be a nicer or easier way to do it. Okay? So, my next step will be to ram up the flasks to, push this, pardon me, push this shaft and crossfeed nut assembly into the sand to make the whole thing and pour it, and we'll see, because we'll be able to just take it off when it's done, and we'll be able to examine on the inside to see if there was any defects, whether there was trapped sand, whether there was maybe some gas in there that made a bubble inside there instead of having a nice solid female thread in there. We'll examine it. We'll look close to it. But I have not much worry about that. I think this is going to be a piece of cake, but I've never done it before, so it's going to be an experiment. Okay. So the next video that you see is going to be in a couple of days, and it'll be me ramming this up, getting it ready, and pouring it on that day. Okay. So give me some feedback on this, if you would. Go ahead and give me a thumbs up if you would, or a thumbs down. Tell me what's wrong with if you do a thumbs down, tell me what caused you to be doing the thumbs down, and spread the word to your friends and relatives that like to work with foundry stuff, that what we're going to be doing, or what I'm going to be doing. Okay. So liberty call to all you ex-Navy or stay Navy, full-time Navy now, and please be careful, and come back and see me again. All right. See you later.